Oh, hey, everybody. It is Monday, April 9th. It was a cold day today. It was only about 35 or 40 degrees today. We're pretty sick of this weather. We're hoping by Thursday the temperatures are going to be close up to 80, more spring-like. But today was Monday, April 9th, and today was an A day. So I met with first block and seventh block today. Many people stayed after school today for after school help. It was great. Students were finishing up tests if they haven't done them yet. They were doing test corrections and they were getting a lot of good work done. So today, Monday, April 9th, 2018, it's an A day. Today's objective was I can model a watershed in order to create a definition of the components of a watershed. We started off class by taking some notes on watersheds and on river systems. And then we finished off class by doing a packet on the different stages of a river, the youthful stage, mature stage, and old stage. Students did turn that packet in, and that is a 10-point assignment. A river cuts through a rock, not because of its power, but because of its persistence. This is such a great quote and totally related to what we were learning about today. How a river is just made up of water, and water is just not even anything that anybody thinks of as very powerful. But over time, a river can really have a big difference in an area, in a landscape. It can cut down. It's constantly cutting down to sea level. And the same goes for all of us. We are, over time, really being persistent in making sure that we get our work turned in on time, that we're coming after school for extra help, and getting things done. Here's a watershed. A watershed is this whole area, all of the land, and all of the rivers and little tributaries that lead into the river of a certain area. And it's the area that's sort of like a basin. So it's all, the divide is this highland here, and then the watershed is all of the land that's going down from the divide. Here's another picture, and this is showing the stages of stream or river development. So you see up at the top that you have a young stream. Young streams are the source of the river. It's a steep slope, therefore the velocity is high. And this, at this stage, the river is moving large boulders, large pebbles, sand, as well as sediment like silt or clay. In the mature stream, you have a moderate slope, so it's not as severe. The velocity or the speed of the river starts to slow down, and the river starts to meander or bend back and forth. When you get closer to the ocean, you have an older stream or river, and it has a very gentle slope, almost zero slope. It's almost totally flat. And the river is really bended. It almost looks like a ribbon. It's going back and forth, and it's been moving back and forth for years and years. You often see oxbow lakes, which used to be attached to the river, but they've been cut off. And eventually the river's mouth will make its way all the way to the ocean. When it hits the ocean, the velocity drops dramatically, and so the river drops any of the sediment that it has and forms a delta. Here's a diagram that's showing you why rivers move. Rivers are constantly moving, especially the closer they are to the ocean. And you see in this diagram here, the dark blue is the area of the river that's moving the fastest. And you also see on some side you have erosion. So on the outside of the curve you have erosion where the dark blue is, where the river is moving the fastest. But on the slow side, which this is a cross section down here, on the slow side the water slows down. And we know when water slows down, it starts to deposit sediments. So you have a buildup of sediment on the slow side, and then you have an erosion or cutting of sediments on the fast side. So that happens on the outside of the curves, and then you see it comes up here and you have erosion on the outside, and it comes down here and you have erosion on the inside. What happens over time is you really cut the outside of the curve and you really build up the inside of the curve, and the whole river actually starts to move. Here's another picture of that happening here. So you have the outside of the curve being eroded here, and being eroded here. And over time, those curves get closer and closer. So the river is moving closer and closer until eventually there's some sort of flood or something like that, and the river water will jump over, because river always wants to take the path of least resistance. And when it jumps over, it cuts off this curve of the river, and this is called an oxbow lake. This will be completely cut off of the river, and eventually the river is going to move somewhere else. So those were the main points from today's class. Today's class was all about watersheds and river development, and how rivers are carrying sediments and how they're eroding the river banks from side to side, or when they're really young rivers, how they're just cutting straight down. Now for homework, you have to finish your stages of river development packet. If you did not finish that in class, that's a grade that you want to pass in. Also, you want to be finishing up your SOL review assignment. Your SOL week 1 review assignment that has 4 components is due on Wednesday, April 11th. So you have your packet, you have your sketch, you're going to turn those 2 in together in class on Wednesday, and then you have 2 assignments online. One is a JLab, you're going to take a screenshot of that and attach it up on Google Classroom, and then the other is a practice quiz on Google Classroom. Those 2 are 10 questions each, and those you have until 11:59 on Wednesday, April 11th. You want to make sure that you get those assignments done, because we are not accepting any late work on the SOL review assignments. Hope you have a great afternoon. I will not see you on Wednesday because I have to be out for some other business, but I'm leaving some work with the sub, and I will see you on Friday. Have a great week, and I'll talk to you soon. All right, bye-bye.